Example 4 on equations in irrational surds form. We have solved the equation 2 times square root of 3x plus 4, that's 3x plus 4 under square root, plus x, which is outside, equals 36. This question is quite different from the previous ones, and you have to be careful approaching this question. Let's say you intend to solve it and you try to solve it by squaring both sides at this point. Your work will get more complex. So the best thing to do is to get this plus x outside first and see if you can get these two out, then solve for the rest. So let's say we write out the question. We have 2 square root of 3x plus 4 plus x equals 36. First, you take out this x. If you intend taking out this 2 is multiplying with 3x plus 4. That means you have to divide both sides by 2. If you divide both sides by 2, this 2 will disappear from here, but this x will be over 2 since they are linked by addition. Then this 36 will also be divided by 2, which will give you 18, but the x here will now be a fraction. And if it's possible to avoid fractions, we solve avoiding fractions, but that doesn't mean you won't get the answer. But let's go this way. You have 2 square root of 3x plus 4 equals 36. Then the plus x crosses the equals sign and becomes minus x. At this point, you can also choose to divide both sides by 2. But once you do, this 2 will leave this place. Then you have 36 minus x over 2. That will be a fraction. And if you have an option of avoiding fractions, you can apply. So in this case, to avoid having fractions, we square both sides. We square the left side and the right side. Let's work on this bracket. Since the 2 is linked to the root 3x plus 4 by times, you can give it a separate square and give this also a separate square. So you have 2 square times root 3x plus 4 square equals, on the other side you have 36 minus x square. 2 squared is 4, that's 2 times 2. That's 4 times. For the second part, the square cancels the square root. That's the reason why we squared both sides, to get rid of the square root. You'll be left with 3x plus 4 in brackets, because it's one entity at this point. And if you don't put it in brackets, all it means is you just do 4 times 3x, you get 12x. Then you put this plus 4 at the back. But if you have a bracket, it means the 4 affects both the 3x and the inner plus 4. So this means something different. Equals, on the other side, we have 36 minus x squared. You can choose to expand by doing 36 minus x in one bracket, 36 minus x in one bracket, and expand that way. Or you can apply the formula where you have a minus b squared is the same thing as a squared minus 2ab plus b squared. And in this case, 36 is a and x is b. So we're applying this to solve the question to make us move faster. Now we'll take 36 squared, that's our a squared, minus 2 times, it's 2ab, that's 2 times a times b. Your a is 36 times, and your b is x plus, it says b squared, that's b in this case is x, so you have x squared. On the next line, you do 4 times 3x, you get 12x, then 4 times plus 4 will give you plus 16 equals 36 squared minus, you have 2 times 36 times x will give you 72x. That's 2 times 36 is 72. 72 times x will give you 72x. Or you can say minus 2 times 36 will give you minus 72. Then minus 72 times plus x will give you minus 72x plus x squared. Like said in the previous question, I don't like my x squared or the letter with the power of 2. When it comes to working with quadratic equation, I don't want it negative. So I rather move what is on the left to the right. I can take this first, so it looks in order. You have x squared, take that first, minus 72x. This 12x as a positive is crossing to the right, so the plus 12x turns to minus 12x. Then you have plus 36 squared. 36 squared is plus 1296. Then the plus 16 on the left, we are moving it also inside. It crosses the equals sign and turns to minus 16. Now, because we don't want our x square negative, we moved 12x plus 16 from the left to the right. We have them on this side and we arrange them in terms of like terms. You know you have to have your equals to sign on this side, then you have 0 because you've moved everything. But you can write it on this side, it's allowed in math. You have equals 0. Next you have x squared, then you have minus 72x minus 12x. These are like terms. You are owing 72 and you are owing 12. That means you'll be owing much more. And if you are owing much more, that's minus. Then that means you have to add your debts together. So 72 plus 12 will give you 84x. Then you have plus 1296 minus 16. With your calculator, that will give you plus 1280 equals 0. Now you have a standard quadratic equation, and you can look for two numbers that you multiply to give you 1280, yet when you add them it gives you minus 84. If you have like minus 84 in this case and you have a positive here, that means the two numbers will have to be negative for you to get a negative. And we already know it, although you can also try to figure it out on your own by pausing this video and try to find the two numbers that you multiply to give you 1280, yet when you add them they give you minus 84. The two numbers are minus 64 and minus 20. Since we know the two numbers that you multiply together to give you plus 1280 are minus 64 times minus 20, and yet when you add them together you still get minus 84. So what we've done is we've broken down minus 84x into minus 64x and minus 20x using this 1280. So we have x squared minus 64x, you have to include x to this 64 and also this minus 20, minus 20x plus 1280 equals 0. We've broken it from 3 terms to 4. We have 4 of them here. We group them in 2s. We have this 2 and this 2. Note this 20x owns this negative, so we are putting in bracket the 20x with the negative it owns. Next we go and look for what is common in both x squared and minus 64x. You know it's x. Take out x, you'll be left with x after dividing x squared by x, and also after dividing 64x by x, the x will cancel with the x, leaving the minus 64. So you have minus 64 here, close bracket. Now what is common in these two? 20. You can find 20 in 20 and you can find 20 in 1280. You have to take the highest common factor. 10 can also go in both of them, 2 can also go in both of them, but you have to take the highest common factor, which is 20. You're not just taking the 20, you're taking it with the negative. So what is in the second bracket will be the same thing as x minus 64. So we have minus 20, you open your bracket, minus 20x divided by minus 20. Negative divided by negative will give you positive. You can choose to write your positive or leave it empty, then 20 cancels 20, you'll be left with x. Since you removed minus 20, you have to be very careful here, because this negative will change the sign of this positive to negative. It's just simply saying plus 1280 divided by minus 20. Positive divided by negative will give you negative. Then 1280 divided by 20 will give you 64. You close your bracket equals 0. Since you have x minus 64 here and x minus 64 here, you pick one. That's x minus 64 in one bracket. Then in second bracket, you have x minus 20. Those outside, you put them in one bracket. That's x minus 20. Close bracket equals 0. You have x minus 64 equals 0, or x minus 20 equals 0. X equals minus 64 crosses and becomes plus 64, or you have x equals minus 20 also crosses the equals to sign and turns to plus 20. So you have x is 64 or x is 20. We're not done with the question. We have to then insert the numeric values for x into the original equation to see if what is on the left is same as what is on the right, and if not so, we call it an extraneous root. So let's insert them into the equation. As you can see, the equation on this side, you have 2 square root 3x plus 4 plus x equals 36, and you know our x is 64 or x is 20. Let's start with the 64. X is 64. So you have 2 square root 3x plus 4 plus x equals 36. X equals 64. You have 2 times root 3 into open bracket 64 close bracket. That is, we've changed the value of x to 64. So we have 3 times 64 plus 4 plus 64 equals 36. We have 2 times, you have square root 36 times 64 is 192 plus 4 plus 64 equals 36. Now you have 2 times square root of 192 plus 4 will give you 196 plus 64 equals 36. 2 times square root of 196 is 14 plus 64 equals 36. You have 2 times 14. 2 times 14 is 28 plus 64 equals 36. You have 28 plus 64 will give you 92 equals 36. You see that what is on the left is not the same as what is on the right. Therefore, 64 is an extraneous root or an extraneous value for x. Next, we try the x equals 20. We know our initial equation is 2 times square root of 3x plus 4 plus x equals 36. Let's take when x is 20. Would what is on the left be the same as what is on the right? Let's solve to prove. You have 2 times square root of 3 in bracket 20 plus 4 plus, x is 20, this external x, so you have 20 equals 36. You change the value of x to 20. On the next line, you have 2 times square root of 3 times 20 is 60 plus 4 plus 20 outside the square root equals 36. You have 2 times square root of 60 plus 4 is 64 plus 20 equals 36. You have 2 times square root of 64 is 8 plus 20 equals 36. You have 2 times 8 is 16 plus 20 equals 36. 16 plus 20 is 36 equals 36. That means what is on the left is the same as what is on the right. Therefore, the value for which x gives us the same value as what is on the left to what is on the right is x equals 20, which is the solution to the equation. So therefore, the answer to this question is x equals 20.